Hey everyone! Ever wonder how your brain remembers a phone number long enough to dial it? Or how a chatbot can hold a conversation without forgetting the context? It turns out the secret lies in memory, but not just any memory. Today, we're diving into how researchers are borrowing ideas from human brains to build smarter, more adaptable AI. Let's start with a simple truth. Memory is the foundation of intelligence. Whether it's a human recalling a childhood event or a computer processing a sentence, memory lets us learn, reason, and adapt. But here's the catch. Traditional AI models, like the powerful transformers we use for everything from translation to coding, have a big blind spot. They struggle with long-term context, get stuck in rigid patterns, and use way too much energy. Think of it like trying to remember a recipe while cooking. If you only keep the last few steps in your head, you'll probably mess up the dish. That's basically what happens with current transformers. Their short-term memory is limited, and they can't efficiently store or retrieve information over long periods. Plus, they're like energy-hungry machines, processing every detail from scratch, even when they've seen it before. So how do we fix this? By looking to the human brain, of course. Our memory isn't a single storage unit. It's a dynamic system with three key parts. 1. Sensory memory, a fleeting snapshot of what you just saw or heard. 2. Working memory, the mental workspace, where you juggle ideas and solve problems. 3. Long-term memory, the vault where experiences and knowledge are stored for years. Memory-augmented transformers aim to mimic this structure. They use embeddings to create short-term feature maps, attention mechanisms to focus on what matters, like working memory, and specialized memory banks to store knowledge long-term. It's like giving AI a brain that can both think on its feet and recall the past. But here's the cool part. Researchers aren't just copying biology. They're blending neuroscience with engineering to create adaptive systems. For example, some models now use hierarchical buffering to organize information, or surprise-gated updates to decide what's worth remembering. It's like teaching AI to prioritize what's important, just like humans do. Of course, there's still work to do. Scaling these systems without losing efficiency remains a hurdle, and preventing catastrophic forgetting, when AI unlearns old info while learning new stuff, is tricky. But the progress is exciting. Imagine AI that can learn from experience, adapt to new situations, and remember things the way we do. So what does this mean for the future? It's not just about smarter chatbots or faster translations. It's about creating systems that truly understand context, reason with flexibility, and grow with every interaction. And that's just the beginning. Stay curious, and we'll keep exploring the mind-bending world of AI together. But let's get technical. How do these memory-augmented models actually work? Traditional AI is like a sticky note. It holds info temporarily, but struggles with long-term retention. Enter systems like Memformer, which uses LSTM-style gates to decide what to keep or erase. Think of it as a librarian with a magic scanner. It flags important documents and shuffles the rest into storage. Then there's memory-augmented, which acts like a detective in videos, keeping only the most reliable object tracks by adding confidence gates and letting less important data fade over time. But storing isn't enough. AI needs to integrate memories into its thinking. That's where attention-based fusion comes in. Imagine a detective sifting through clues. The model focuses on the most relevant stored data, ignoring distractions. It's like having a mental spotlight that highlights what matters. And then there's gated control mechanisms, which act like a brain's own editor. They decide what to prioritize, what to archive, and what to forget, kind of like how your brain tunes out background noise to focus on a conversation. Now let's talk about forgetting. It's not just about deleting old data, it's about smart pruning. Models like Memlong delete outdated info when it's no longer useful, while memory-augmented lets unreliable data fade naturally. Even Titans and Atlas use adaptive gates to decide what to keep, like a brain that forgets irrelevant details to make space for new knowledge. It's a delicate balance. Too much retention and the system gets cluttered. Too little and it loses context. But here's the real game changer: capacity optimization. How do these systems grow without exploding in size? They use compression, hierarchy, and sparsity. The compressive transformer shrinks old data into compact codes, while LM2 builds tree-like structures to fetch details quickly. And memory layers at scale shard data across GPUs, making billion-entry memories possible without slowing things down. It's like giving AI a cloud storage system that's both fast and efficient. Ever wonder how AI really processes all that information? Let's break it down. Traditional AI models work like reading a book, step by step, from start to finish. But here's the twist. The newest AI systems are starting to think more like our brains. Instead of just following a strict path, they can zoom in on the most important details, like how you spot a familiar face in a crowd while ignoring the background noise. How do they do that? Some researchers are tapping into clues from neuroscience. They're looking at brainwave patterns, like gamma power, which spikes when we're focused and processing complex ideas, and alpha power, which helps us filter out distractions. By mimicking these rhythms, AI models can prioritize what's relevant, store information more efficiently, and retrieve it faster. It's like giving the AI a built-in spotlight for important data. The result? Systems that don't just follow rules, they adapt. Imagine a chatbot that remembers your preferences over time, or a robot that learns from its mistakes like a living creature. These models are getting closer to something truly remarkable. Intelligence that's not just programmed, but responsive. And here's the kicker. Scientists are still figuring out how the brain's own memory systems work. By reverse engineering those secrets, we're not just building smarter machines, we're rewriting the rules of what's possible. So what happens when AI starts thinking more like us? Let's find out